Algebra 2 Final Review Solutions. In question 13, you're taking the fourth root of 81, x to the 8th, y to the 6th power. We could break this up into be the fourth root of 81, which is 3, the fourth root of x to the 8th, which is x squared. The fourth root of y to the 6th power is a little less easy to compute because you're going to have to split this up into the fourth root of x to the y to the 4th and the fourth root of y to the 2nd power. The fourth root of y to the 4th would be y. The fourth root of y to the 2nd power would stay under the radical. And it's easy to see how the 3x squared came out relatively easy. And then you have the fourth root of y to the 6th power left. Another way is to connect rational exponents with radicals. The numerator of the rational exponent is the power, and the denominator of the rational exponent is the root. So here we are going to re-express this as y raised to the 6/4 power, since 6 is the power y is raised to, and 4 is the root that it's being taken of. And 6/4 can be reduced to be 3/2. So another way of writing that expression in simplest form is 3x squared y to the 3/2. In question 14, choice 1 is the exponential situation in the chart. We know this because x is growing steadily, but y is halving each row. Question 15, we are finding the roots of x squared plus 2x plus 5. A is equal to 1, b is equal to 2, c is equal to 5. We make our substitutions, and then under the square root, this is going to evaluate to be 4 minus 20. So that's going to be x is equal to negative 2 plus or minus the square root of 4 minus 20 over 2. That could be simplified into be x equals negative 2 plus or minus the square root of negative 16. When we have the square root of negative 16, we could break this up into the square root of 16, which we know is 4. And then we also have the square root of negative 1, which we know is I. So this is going to be 4i. So this is going to be x is equal to negative 2 plus or minus 4i over 2, which can reduce to be negative 1 if we divide all of those real number pieces by 2. Negative 1 plus or minus 2i. So x could be equal to negative 1 plus 2i, or x could be equal to negative 1 minus 2i. That's 15. Number 16, we have the function or the polynomial p of x equals x cubed minus 3x squared minus 2x plus 4. We know that the following statement is true. We know that x minus 1 has to be a factor, because if we evaluate the function at 1, which means that 1 is a root, it's equal to 0. And we know that factors and roots have opposite signs. If we plug in 1 here, 1 cubed is 1, minus 3 times 1 squared would be minus 3. Minus 2 times 1 plus 4. So we have 1 minus 3 is negative 2. Minus 2 is negative 4. Add on the 4 at the end and you get 0. Since the output is 0, we know that 1 is a root. If 1 is a root, then x minus 1, the opposite sign, is a factor. In question 17, we know that p of x is equal to 3x cubed plus x squared minus 5x. Since the highest exponent is 3, that's a third degree. It has three roots. And we know that m of x, which is this graph, would have 2 real roots, because those are the only roots that intersect the x-axis. The next question that we have is 18. We're taking 2x to the 4th power plus 8x cubed minus 25x squared minus 6x plus 14, and we're dividing it by x plus 6. we're dividing polynomials, so we could use, in this case, we can use synthetic division. Sometimes you could only use long division, but you can use synthetic here, so that's the way I'm going to go. I'm going to write the coefficients of the numerator, or the dividend, 2x to the fourth, and then 8 for x cubed, negative 25 for x squared, negative 6 for the x to the first term, and then 14 for your constant. I'm going to put it backwards L. In that backwards L, I have a divisor of x plus 6, so I'm going to put the opposite sign, which would be the negative 6. Since we know that factors and roots would have opposite signs, that's the way this procedure goes. Horizontal line, you're always going to bring down that first coefficient as is, so that's a 2. Then multiply that number by the number in the backwards L to get a negative 12. 8 minus 12 is negative 4. I now take the negative 4 and multiply by the number in the box, or the backwards L, negative 6. That's going to be a 24 when multiplied. Negative 25 plus 24 is negative 1. Take negative 1, multiply by the number in the box. Negative 1 times negative 6 is positive 6. Add these up, you get a 0. Multiply 0 by the number in the box, you're going to get a 0. There's going to be a 14 at the end. The number at the end is always the remainder. Then you have the constant. Then you have the x to the first power term, then the x squared term, the x cubed term, etc. So your quotient is going to be 2x cubed minus 4x squared minus 1x plus 0 constant, so I'm not going to write it, plus 14, and the remainder is always written over x plus 6. It's always written over the divisor. This would be choice 3. $19. Perry invested in a property that cost him $1,500. 5 years later, it was $3,000. So I'm going to put T for the time, and I'm going to put C for the cost. When he first bought it, it was going to be a time of 0, and that was $1,500. Then 5 years later, it was $3,000. 10 years later, it was $6,000. Assuming the growth rate remains the same, what type of function can help you to create a table of values that helps you to find the value of the investment 30 years after purchase? So we're going to have a way to go until 30, but we have to analyze what we have currently. We have a steady increase of plus 5 each time with the time. So there's a steady increase in input. However, you're doubling the cost each time. Since that's the case, this is an exponential function. Question 20. Which function is best represented by the data in this table? We have x and we have y. X is 0, 1, 2, 3, 4, steady increase in that value, and then you have 1, 3, 9, 27, 81. What we're noticing is, again, steady increase in x, however, you're multiplying by 3, or you're tripling each time. Since that's the case, this is definitely going to be an exponential function. And all exponential functions could be written in the form y equals a times b to the x. A would be your initial value, which was a 1, so I'm going to put a 1 there. That's the initial output value. And then the b would be 3, since you're tripling each time, and raise that to the x power, which is the same as saying 3 to the x power. Choice B.